right, so today we're going to do a lesson that's actually more about how math works than it is actually doing math. So we're going to talk about properties, and most of these properties you've either heard of before, and if you haven't heard of them, you're familiar with them, and we're just going to give them a name today. So the first one on there is commutative property of addition. And if you look, there's a little example here that says, if I want to do a plus b, it's equal to doing b plus a. So an example would be, if I wanted to do 9 plus 2, that would be equal to doing 2 plus 9. It's all about the order of the numbers. And that when it's addition, you can swap the order of the numbers and you still get the same answer. Commutative property of multiplication works the same way over multiplication. So if I wanted to multiply two numbers, let's say 8 times 7, I would get the same answer as if I did 7 times 8. And that is specific to multiplication. Both of these commutative properties have to do with order, changing the order of the numbers. Now, the second property that's there is the associative property of addition. And associative means that we are going to change the grouping of the numbers. So here you'll notice a plus b is in a group together, and over on this side we're going to put b plus c in the group together. Well, because it's all addition on the left and it's all addition on the right, it actually doesn't matter which group the numbers are in. For example, I could do 2 plus 4 and then add 6. It would be equal to doing 2 plus but adding the 4 plus 6 first. This one I'm going to get 6 plus 6 is 12. This one I'm going to get 2 plus 10, also 12. Associative property of multiplication works the same way. If I wanted to do 1 times 3 and then on the outside plus 7, I'm going to get the same answer. I'm sorry, that should be multiply on that one because this is the associative property of multiplication. And if I want to, on the other side, have the 1 first times, and then in the second set, 3 times 7. On the first one, 1 times 3 is 3, times 7 is 21. Or I can do the 3 times 7 first, which is 21, times the 1 stays the same. So the two associative properties are about changing who is in the group. So there's an addition property for commutative, and there's an addition property for associative. There's a multiplication property for commutative, and there's a multiplication property for associative. So it's really important to look at whether or not you've got addition symbols or multiplication symbols, whether you're changing the order of the number or you're changing the grouping of the number. Now, the next one is called the additive identity. So this is about a number keeping its identity. So if I start with a number and add 0, let's say 13 plus 0, that would be the same or equal to doing 0 plus 13. And in both cases, the number 13 gets to keep its identity. It stays 13. If I want to multiply and have a number keep its identity, I could multiply the number. Let's say it is 11 times 1. That's going to be the same as 1 times 11. And in either case, the number 11 gets to keep its identity. Last but not least is the multiplicative property of 0, which is a mouthful. But you need to remember that it has to do with multiplying and 0. So if I multiply by 0, notice this is the only property with the word 0 in it. Multiplying by 0, what happens? If I do 5 times 0, it is exactly the same as doing 0 by 5, and both of them result in an answer of 0. So the only one where the answer is 0 is the only property that has 0 in the name. Now, if we look at an example, we can name which property it shows. So on this first one, do you notice that the 7 and the 3 are in the parentheses, and over here the 7 and 3 are still in the parentheses? Well, that means it's not one of the associative properties because the group, the 7 plus 3, stayed the same. That means it's got to be a commutative where we change the order. So here I started with the 4 plus, here I ended with the plus 4. So this one is a commutative property, and I have to remember that it is addition. So not only that it's commutative, but also that it's addition. The next one has x plus 9 in the parentheses, and the other parentheses have a 9 and 7. So the numbers in the group have changed. So this is a group question, so it is associative property of, and then I'm going to look back, addition. Then I've got y plus 0 equals 0. So the y stayed a y. It kept its identity. That makes it the additive identity property because it was addition. And then we've got this one. So I'm going to look in the parentheses 5 times x. And this one, the group has changed. Now it's 3 times 5. That tells me, since it's a group change, that it's going to be associative. So it's going to be associative property of, and then I'm going to double check. This one has the dots, so it is multiplication. Don't really need to write out all of multiplication, but you can. And then I've got 8 times 1 equals 8. The 8, we did something to it, and it stayed an 8. It kept its identity, and it's multiplication. So this one's going to be the mouthful. Multiplicative identity. Last but not least, we've got 7 times 5 times 2, 5 times 2 times 7. Notice there's no parentheses anywhere in it. The fact that there's no parentheses anywhere in it tells us that it can't be a group change. It can't be associative. I also don't see any ones or any zeros. So I'm down to only the commutative properties. And since it's multiplication, I'm just going to look. There's a 7, a 5, and a 2. There's still a 7, a 5, and a 2, but the order has changed, making it the commutative property of multiplication. You can shorten that up. All right, so that's how we identify which property goes with an example. And then here, it's saying let's use those properties. So how could we simplify this by using the commutative property? Okay, so the commutative property talked about changing the order. So in this case, if I want to change the order, I might start with 7 plus and then put the 3 plus x after the 7 plus. What if I wanted to change it using the associative property? Well, in that case, I'd need to change who was in the group. So maybe the 7 plus 3 is in the group now, and the plus x is outside of the group. In this case, do you notice how I ended up with two numbers that are actually digits? I can do 7 plus 3 and get 10 plus x. Remember, though, we are better off having the variable listed first. So in this case, the better way to write that answer would be x plus 10. In simplest form, we only have one term with a variable. We have one constant that has no variable, nothing else that can be added or subtracted. Now, when you look at the back, we do have a second example like this. This one's multiplication, 8 times, and in parentheses, y times 5. Commutative, that's the one that tells us that we are going to change the order. So I'm going to put the y times 5 first, and then I'm going to end it with the times 8. Associative property, who do I associate with? Who's in my group? So I associate here, the y and the 5 are in the group together. So I'm going to change who's in the group. And now I'm going to put the 5 times 8 in the group together. And notice what I did. I got the two digits, 5 times 8, which I know are worth 40. So I would have y times 40. Best way to write that is with the number, the coefficient, in front of the variable. Now this is multiplication, so we could write it with the number bumped up against the variable, and the number always comes first, variable comes second. That is the best way to leave our answer. And that's really what all of this lower half is going to come out to be. Can we do any combining to simplify, to make this simpler? I notice there's a 12 and there's a 4. Everything is addition, and 12 and 4 are both constants. So I could add them together and get 16 plus m, the better answer having the variable first, m plus 16. On this one, I've got a 3 and an 8, all addition across the board. So I could add the 3 and the 8 and have 11 plus k, the better order with the k first, k plus 11. Now, some of you might start going, Mrs. Fraser, why are you bothering? Why are you writing 11 plus k if you just know you're going to switch it? Guys, you can skip that step. There's no reason to write 11 plus k if you know k plus 11 is the better way to write it. So here I'm saying, okay, 15 plus s plus 4. 15 and 4 adds up to 19. Everything is addition. And I've got an s. So you know I'm going to tell you to write the s first. So s plus 19 and you're done. The best way to write your answer has the variable first. And it is added first. And we're gonna specify that it's added first because it is slightly different when you go to multiply. Here we've got D plus 12 plus 16. I can add the 12 and the 16 and get 28. So D plus 28, no reason to write 28 plus D. 14 plus 27 plus R, even though it's all addition and we've got this weird parentheses at the end, we know that we could think of it. Yeah, I guess I'll use blue, doesn't really matter. We know we could think of it this way. So 14 plus 27 would be 41 plus R, and then you notice, oh, well, you did the 41 first. We're going to rewrite it. R plus 41 is the better answer. And then here, same idea. The 54 and the 16 would add up to 70. So P plus 70, P first being the better answer than 70 plus P. Now we're going to switch to the multiplication. And the same idea holds true. If it's all multiplication all the way across, we can change the order. We can change the grouping. So I can do 8 times 5, which is 40. And then the x just becomes 40x. Now, this 40 times x means the same thing. This is your answer in simplest form without the dot. If you can write it without the dot, that is your better answer. So 10 times f times 5. If I think about doing the 10 times 5, I would get 50. And the f, no dot, number comes first. 12 times a times 6. I'm going to multiply the 12 and the 6 since everything is multiplication and get 72a. So notice that when it's multiplication and the number and the variable are attached, we're writing the number first and the variable second. So number first, variable second when multiplied. And you guys know this is hashtag, but it also means number, just for the record. 11 times t times 4, I can do the 11 times the 4 and get 44. And remember we said in the previous lesson, if we're going to write a t, we've got to curve the bottom of it so people don't think it's a plus sign. This is the same as this or this. It's all multiplication. So we are going to tighten that up and say, okay, well, what is the 15 times the 2? It's 30. And then we put the b on there for 30b. But those all mean the same thing. It's just a different way of writing multiplication. Same over here, the 6 times the 10. We could regroup this and say, oh, I can do 6 times 10. It is 60. And then just tack the c on there. So hopefully this one was pretty straightforward and you're thinking, no problem, Mrs. Fraser, I got this homework. But if I don't, I'm going to make sure that I sign on and ask some questions. All right, guys, see you in class.